Okay, we're going to get started today with inscribed angles, but before you get started on this note packet, I want to make sure that everybody downloads and prints off or has for easy reference somewhere this strategy sheet. I called it Angles and Circles Strategy Sheet because I'm going to throw at you several strategies today. Here, I'll click over to it. So we're going to look at for sure 3 of these major strategies, and it's real easy to get them confused. And so having all the strategies on one sheet where we can compare them um, and figure out which strategy to use is helpful. So make sure you print that off or have that out beside you as we get started here. So just as kind of a little segue from yesterday we had or maybe it was a couple of days ago, we had central angles. So we were talking about that this angle right here is called a central angle, and that however much that it's a central angle because its vertex is on the center of the circle, and if this is like 80 degrees, then the matching arc, the corresponding arc, we're going to learn a term for this in just a minute, is also 80 degrees. So today we're talking about angles that are located differently. So first of all, what is an inscribed angle? An inscribed angle is an angle that has its vertex on the circle itself. So this right here is an inscribed, we know that means inside, inscribed angle, and its vertex is on the circle, which is different from our central angle whose vertex was on the center, right? And so the intercepted arc, the other piece that you need to know, is that's the name for the arc in between the 2 legs of the angle. So this is the intercepted arc. Okay. And it says where formed where the endpoints of the sides intersect the circle. It's just saying the legs intersect the circle. All right, so here's our first theorem for today. It says the measure of an inscribed angle is half the measure of its intercepted arc. And if you think about it, this makes sense, right? Because the farther away you are, like point B is much farther away than the central angle that would have been right here. It's because it's farther away, it has a longer time for this angle to get bigger and to increase and to get wider. So now if this is, we'll say 100, I'm just making up numbers here, then angle B is 50. So again, when is it half? It's half when the vertex is on the circle. They're the same amount when the vertex is on the center. So if you look at your strategy sheet, we've talked about the central angle, which is strategy 1, and we just introduced strategy number 2 when the vertex is on the circle. All right, so let's look at example 1. Identify the inscribed angle and its intercepted arc. So in example 1, the inscribed angle is angle D to the E to the F, or you could even just call it angle E. And the arc that goes from one place to the other as far as the intercepted, the intersection of those legs and the circle itself, if you follow that around, it would be arc DF. So it should be in between the legs of that angle. So that's pretty not too bad. On the U try though, you have 4 angles, A, B, C, and D are all inscribed angles. Let's look for example at A. So here is A, and I highly recommend using some colored pencils or something to trace out the legs of that angle. Otherwise, it can be difficult to tell where exactly the intercepted arc starts and stops. So what you're looking for is you want to be on the inside of that angle, follow it all the way out to the end, and then where that angle crosses the circle, that's where you start, and you go all the way around to where that ends where the leg intersects the other side of the circle. So A is intercepted arc. This is possibly a major arc or a semicircle, so we need to be sure to use 3 letters. It would be D to the C to the B. Okay, let's look at another one. Let's look at angle B. Same picture, all new scenario. This time, if we start where the angle crosses the circle, we follow it all the way around to where the angle intersects the circle. We were using A to the D to the C. And keep in mind, the order doesn't matter, clockwise or counterclockwise. You could also name this C to the D to the A. You could have named the first one B to the C to the D. Okay, so if you will now pause the video and you try the last 2 on your own. Okay, for angle C, you should have had arc dab or arc bad, either way. And then for the last one, angle D, we should be A to the B to the C, or other way around, that's fine as well, C to the B to the A.